Hey everybody, this is a video that's going to explain how to write names from formulas. This is question number 23.37 out of Braun-LeMay Burston 13th edition, and let's get started. I feel like the only way to really improve on this is to just keep working through examples. There's rules for naming that you can look up, you can get from books, whatever it is, but you really have to just apply those steps and then just keep practicing those steps until you're like, oh, I get it. And so, and that's the way it is for a lot of things that are just prescriptive, like this sort of thing. So let's start here. So again, I think that whenever you have a formula, you should just be able to split this in half and know that this second half is not part of the complex ion. Okay, this is just the chloride ion, and that's going to go at the end of the compound. So now what we have to do is we have to know what this is and what this is, because we have to list the ligands off of in the complex ion in order. So this, or in alphabetical order. So this is amine, okay, and this is chloro. So when we do this, it's going to be tetra, because there's 4 of them, tetraamine, and then 2 chlorine, so it's dichloro. Remember, the prefixes don't count in terms of alphabetizing. So we've named this part and this part, so now we need to know RH is rhodium. Okay. And now we need to know what the oxidation state of the rhodium is. So this is where we have to go back and kind of make sure that we know what we're doing. So chloride is a minus, so that means that this side is a plus. Okay, this side is a plus. So this is going to be 0. Amine, it has a 0 charge. It's the ammonia compound, and so it's just a ligand with no charge. And each of these is a minus, so this is 2 minus. Each of the chlorides is a minus, so that's 2 minus. So the only way for rhodium, or for this complex to get up to a plus charge, is for rhodium to be a 3 plus. Okay, so then this is going to be rhodium 3, and then the chloride here, the chloride comes down and is the end of that. Okay, so these names are going to be long and ridiculous and sound kind of funny, but that's just the way it is going to work. Okay, so that's the name of this first one. So now let's look at the second one. Okay, so now again, there's 2 parts to this. You can see that this is the potassium. So that's the first half. That one's fairly straightforward. And now we have to name this complex ion. Well, there's only one ligand sticking off of this thing. It's just the chloro ligand, and there's 6 of them. So it's hexachloro. And that's titanium. Okay, so remember, when the metal is part of the negative side, the anion part, it has to end in 8. So titanium turns into titanate. Make sure I put the emphasis on the right syllable here. Okay, so now we need to figure out what the charge is on this thing. So remember, each potassium, if I take this thing and break it down, okay, each potassium is plus, so this side is 2 plus, so that means that this is going to be 2 minus. Each chlorine is a 1 minus, so that means that this is 6 minus. So the only way that this ion can get up to 2 minus is if titanium is a 4 plus charge. Okay, so that's potassium hexachlorotitanate 4. like I said before, it just sounds silly, but that's the way it goes. Okay, so now here's a complex compound. This is just a coordination compound. It's not an ion. It's the compound. So so we have, if I can spit it out here, this is molybdenum. Okay, and molybdenum, we need to know what the charge on this is. So so this is oxygen and chlorine. Chlorine is minus, so that means that this is 4 minus. Oxygen is 2 minus, that's the oxo ion. And so that means for this to all total out that this molybdenum has to be 6 plus. So we're going to start from the back, and we have to, because we have to put the metal at the end. So this is going to be, let's see, and again, it has to go in alphabetical order. So this is chloro and this is oxo. Okay, so this is going to be tetra, chloro, oxo, molybdenum, 6 Vi. Okay. Whew. Again, it sounds weird, but that's the way it is. Okay. Now the last one here. Okay. So again, we have this broken up. We have the bromide here, which we can put at the end after we do that. But we need to name this complex ion here. Okay. So we're going to name the 2 parts, are the 2 ligands, and then we're going to name the metal. So we have to know what the names of these things are. This is the aqua. It's water, and remember, water has a special name. And this is the oxalato ion, oxalato. So the name of this is going to be tetra, aqua, oxalato, platinum, PT is platinum, and now we need the charge. Okay, so water is 0, oxalato is 2 minus, there's only one of them. Okay, bromine is 2 minus. So that means this overall charge has to be 2 plus in order for the cancel out the 2 minus. So how are we going to get 2 minus to equal 2 plus? So that means that the platinum has to be a 4 plus. So again, that's going to be 4, and then bromide goes at the end, B-R-O-M-I-D-E. Okay. So there it is, writing naming complex ion compounds from a formula. Okay, have a great day.